In section 2.6, there's a lot of vocabulary that gets thrown at you. And so I want to just spend a little time going over the vocabulary to hopefully make understanding this section easier. The first thing is the term literal will be used again, which we have used before, and that refers to a single variable within a term. So the next term is min term. Min term, if we read this, it says input variables multiplied together. So if you think about this as a gate, as shown over on the right-hand side of your screen over here, when you use an AND gate, this is W, X, and Y, the output, this is going to be multiplication, right? Because it's an AND gate, will end up being W, X, Y, Z. So this would be considered a min term. Okay, so yeah, that's what you need to know. So it is multiplication. So you can think of the end result as being a product. Okay, multiplication is a product. So then you have a max term. And in this, your input variables are added together. So we are looking over here at the OR gate, and you have W, X, and Y, and the output is W plus X plus Y. And if you think of that, an OR gate is represented by addition. So you can think of W, X, and Y as being a sum, because that will help you understand the next slide. So we move on. Okay, so moving on to the next slide. Okay. So moving on to the next slide. So the reason I was using those terms is because there is what they call the sum of products, which you will see referred to as SOP. So if you look over here on the right, all these AND gates are multiplication. So their output is all going to be products. An OR gate is addition. So you can see that these are all added together. And what is getting added together? So this means you are adding together what you had multiplied. I don't know, we're just going to say products. And so adding is also termed as sum. So this is called the sum, because you're adding together, of products, because product is what's going into the OR gate. So I want you to know that in the book, they use the term sum of min terms. So sum of min terms and sum of products are the same thing, or SOP. So then you have what they call the product of sums. So if you come over here and you see that they can be a different amount of gates, right? So these are all OR gates. So these are all adding their terms together. And then you can figure out which each one of these is. But when it goes out here to this will be multiplication. So you will end up multiplying these sums. So you will have some things in here. I don't know how many in here, but they're going to be added together. You're going to have some added together. Okay. And so that's why this is called, because you're multiplying the sums. This is a sum. And this is a sum, and you can have more. So this is called the product of sums. Okay, so when you come back over onto the left, so this is product of sums, also called product of max terms, which you will see in the book. And this gives you an example of an X, Y, and Z. And then in this one, the Z is a prime. The symbol isn't quite right for prime, but good enough. And then there's an X prime in here. So that's not the circuit to the right. That's just an example. So those are a few terms right there that you want to know. So we're going to go on to 2.6. They call the section, they call it canonical. I don't even know how to say this word, canonical and standard form. And I don't know that that's the best name for the section, but we want to discuss these different forms. So the examples on the previous slide were canonical forms. So if you had like X, Y, Z, and then you said plus X prime, Y, Z, whatever it is, plus X, Y prime, Z prime, whatever it is, that is canonical form. So some things to note about it is that now if you had more variables, they would have, every single one would have the number of variables required. So I wrote 3 in here, but if there was 4, they would all have 4. So in this form, all of these have all 3 terms. 1, 2, 3. They all have all 3 terms. That's part of being in canonical form. And the other thing is it says it's a Boolean function expresses either the sum of min terms, which is the sum of products, or a product of max terms, or in other words, product of sums. Okay, so it also says here that canonical forms are achieved by converting directly from a truth table to a Boolean function, which I showed you on the previous video. So then when you look at the standard form, there may be more to this definition, but basically the canonical forms seldom have the least amount of literals, right? Usually you can cancel something out by using your Boolean algebra. So when you have a standard form, those are achieved when you use your Boolean algebra to reduce the number of literals whenever possible. So you may be asking yourself, why? Why would anyone ever want to use canonical form over standard form? And the reason is, or at least one of the reasons is because sometimes it's faster, meaning that it takes less time for the computer. And so if you remember standard form, when we were minimizing things, that was so you're using less gates. So this is a money issue, right? It's less gates, right? Where this is a time. It could be that you want it to run faster. And so we will talk later about how the canonical form creates what they call 2-level structures of gates. And if you look back onto the previous slide, you actually can see this. When I mean 2 levels, this is 1 level, right? And this would be the second level. And so once again, you would have 1 level and you would have a second level. So the signal only has to go through 2 gates to get to the end product. So the last thing that we wanted to look at is, okay, so the last thing I just wanted to talk about was alternative notation. So when you're looking at the table 2.6, you will notice that because there's 3 terms, right? You know, there's 3 terms. So if you say 2 to the third, right? 2 to the n, that means you have 8 possible combinations of those terms. And when you think about it, think about the fact that let's reduce this to a digital number. You got 0, 0, 0. Well, that's 0, right? And the next one, 1, 2, 3, 4, 5, 6, and 7, right? So each one of these, if it's a 0, it goes to x prime. So what this means is x is considered a 1, right? X prime would be that it's a 0. This one's a 0. So I want you to notice here is for each combination that you have, they take this min terms, you can write them as little m and then the subscript of whatever the binary number is from this combination. And for max terms over here, they are using the capital letters with the subscript from the binary combination over here. So sometimes, so these are standard, you know, that it would be x prime, y prime, z prime. So sometimes, say something was x prime, y prime, z prime, plus we'll say x, y prime, z, you would look up here and say, well, that is equivalent to m0, and this is equivalent x, y prime, z. This one is M5. So you could write it in that notation. So for more information about writing out of min terms and max terms, you can go to page 60 in Mano and Ciletti. And it will talk to you more about this, because you can even use, like, there's some summation formula, you know, that you can use. So that's it.